Hello and welcome to another edition of Table Talk. Today our topic is science, and joined by Fumi and our good friend Lawrence, who's going to give us a little insight to the subject. So when we talk about science, I've only got very limited idea because it's such a huge topic in many areas. But you know, watching videos and things, reading material and things, you just sort of gather a bunch of stuff, but you never really get the full broad picture of it. So what comes to your mind when you think about science?
I think of science as a way to discover certain things, because science has got a broad spectrum. It could be geological science, it could be medical science, it could be also sciences. And I think the whole point of it is that you are discovering something that was already there, or you are making something, or you're aiming to make something from what is already there. Your goal is to, wow, this is amazing, or to heal, or to say, oh look, this exists, isn't this amazing? And some people use it to find out where we've come from, or the point of existence, or why certain things work.
Yeah. So it always feels weird to say this. You're a scientist. Because my idea of a scientist is probably going back to the Frankenstein days with some guy creating a bring to life. So Lawrence, tell us a little bit about yourself first, in terms of, you know, you obviously come from Nigeria, so a little bit there, and then how you come to be here and end up the job you're in.
Okay, basically I studied microbiology for my bachelor's at the University of Nigeria, Nsukka, and then I had a scholarship, or fortunate to have a scholarship from the Nigerian government to come here to do a master's in industrial and commercial biotechnology, and when I finished, I really wanted to go back home, but I got some job offers here, so I've stayed ever since. But that's the it's just that exploration, and yeah. Personally, what I wanted to do was to go in and become a medical doctor and all that stuff, but.
As everybody in Nigeria,
yeah, as
medical and accountant,
yeah,
something like that.
Yeah. So, but God had completely different ideas, because every time I wrote the exam, three times, yeah, 2 times I wrote the exams to get into medical school. And the first time I missed the cutoff by 3 points. The second time I missed it by 1.
There's a limited amount of times you can do an A-level, so
yeah.
I think that's it.
Yeah, and then the third time I wanted to do my microbiology and switch over in my second year, and for some reason the year that I wanted to switch over, they had a dean of faculty who said I only want 8 students, and therefore all of us who tried to switch over could not. And that was at the point that I'm like, maybe this is actually where God wants me to be. So yeah.
So you mentioned a whole bunch of words there that I can't even spell, never mind pronounce. Okay. So in layman's terms, what exactly does your job as a scientist involve?
So being a microbiologist, we deal with looking at the minute structure of life, the tiny. So basically, you probably drink a yogurt, or some people drink beer, some have all sorts of fermented foods. Why is it that you leave your food out? Why must you put your cooked food in the fridge? Why is it that when you leave it out on the table, the next day it goes bad? Right? There are tiny organisms that are growing and breaking down these foods. Some of them, when they break it down and the flavor is good or it doesn't cause you an illness, that's when they become fermented foods, and therefore you enjoy them more. So something like yogurt or something like beer, right?
Would blue cheese and that kind of thing also?
Yeah. So literally, when you buy some of the cheeses, you can actually see the mold on the surface. Yeah.
Okay.
But it's the mold in this case doesn't make you ill, but then it improves the flavor of the food. So it's finding out how to refine those techniques to make the product better and all that. And then you have them in and then some of these organisms cause you illnesses, and therefore we have to find a way to find out what exactly is causing the illness, find out what antibiotics to give, what treatment you need to get. And then in agriculture, how to use natural things like your compost and fertilizers to break things down to help your plants to grow. So it's a whole world out there.
Yeah.
And there's so much of it. It's not just the medical, like having not been able to go into medicine, I tried to go into medical microbiology because I still wanted to work in the medical lab anyway. But then instead I've ended up in industrial microbiology and biotech, and suddenly I've seen, oh, this is not just about human beings or animals and all that. There's so much out there too. Most of the things that you buy in your shops, your cosmetics, and now that everybody's trying to go green, so rather than use chemicals to make lots of things, we are now using these microorganisms as mini factories to make the products that we would have used chemicals to make in the first place. But they make these products in such a way that it's natural and can break down quite easily in the environment, and therefore it's more environmental friendly, more friendly to the body or to the earth as a whole. And yeah, that's the summary of it. And yeah.
So, for an example, we spoke about this earlier, but Fumi every year gets a flu jab. We had a discussion about, is that live, is it not live? So you want to talk us through that process of the flu jab. We talk about flu because everybody gets it, and a lot of people have the flu jab. So what's the science behind that? What's the program? How does that work?
So when it comes to the flu jab, so what you do not want is to catch the actual flu itself, or eventually that happen. So what causes the flu? It's viruses. It's even so when you come to microorganisms, we have the bacteria, the fungi. So the bacteria, things like the ones that you find in your fermented yogurt, or if you other things. The fungi are things like the ones that grow the mold on your bread, or the one that you find on your blue cheese and all that stuff. And then you have the viruses, which are even much smaller, and literally they are classified as being halfway between living things and non-living. So what a virus does is that when it gets into your body, it takes over the machinery of your body cells, and it has just one duty: to go into the cells, hijack your cell DNA, and use it to make more copies of itself.
Right.
So it just makes more copies of itself, and then just comes out, and sometimes it will either kill the host or make you really poorly. So with the flu jab, what you are now trying to do is to use those same viruses, but rather than wait till the person has fallen ill, you are trying to give them a small dose of the organism to make your body to respond as if it's under attack. Because each time you fall ill, your body sounds an alarm. It's literally like alarm bells going off everywhere, and your body needs to mobilize soldiers in form of antibodies and all that stuff to go to the site of the infection and fight it. So when you are ill and you are running a temperature, it's not necessarily a bad thing. Your body temperature going up is a sign that your body is actually fighting. Yeah. And then if you've got an infection and you start seeing pus coming out of it, although the pus looks nasty, but you should respect the pus and maybe make a read somewhere, because it's your body cells that have been they're the fallen soldiers.
Oh, okay.
Yeah, right? So these are your white blood cells that have gone to war and have sacrificed themselves.
And they've got to come out somehow.
Yes, and they need to come out somehow, and so they usually come out in front of the as the pus. Or when you've got the flu and you've got the film, it's also the cells that so it's a mixture of the dead cells, the organism that they've killed, and everything which needs to come out somehow. And so that's how once you have a foreign body or an infection, your body sends out all these signals. Look, there's an enemy here, attack, 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 right? And so you don't want to get to that stage where that war is a full-blown war. You want to introduce that enemy a little bit earlier on so that your body can recognize what an enemy actually looks like, and that's where vaccination comes in. So with the flu jab, a certain amount of that virus is made in the factories there. Usually they make them in chicken eggs. So I went to the AstraZeneca site just towards the end of last year. It was literally thousands of eggs everywhere, right? So they inject these eggs into the virus into the eggs, incubate them at a certain temperature for a number of days. Those viruses grow in the egg cells. Of course, it will kill the chicken inside, but just as the way the virus would have attacked you if it was inside you, it attacks the chicken and then uses the chicken cells to make more copies of itself, thereby increasing the quantity which is now harvested, purified, and turned into a little vaccine, which is the jab that you get. So that small jab contains a small amount of the virus, which your body recognizes as an enemy, and then quickly mobilizes all the soldiers to go and fight.
So the virus that's been given is an inactive
one.
Yeah.
So sorry. Virus. So there's something that there is actually sometimes it could be a live one.
But we're talking about the flu vaccine.
But when it comes to the flu virus, it's an they say attenuated, which means that it's made inactive, or it's been dumped down to such a way that it will not cause an aggressive illness, but it's still enough to initiate the response that your body needs to fight against it, so that the antibodies are ready for when the real infection comes, and so you are able to fight off the real flu faster when it's actually there.
You mentioned DNA,
yeah,
and what you were saying. If the virus is affecting the body,
yeah,
so that means it's affecting the body's DNA within each cell. Correct.
So
don't be complicated.
Yeah.
The reason I'm asking this is because even would viruses have DNA?
So
does DNA exist in every living?
Okay, so viruses, certain viruses are, a virus literally is either a DNA or an RNA. Yeah. So these are two different things. A DNA strand or an RNA strand that has been covered up in protein. That just what it is. So, and what a DNA or an RNA is just a series of instructions, right, that have been put together in a I will say in a. So when you get a piece of rope, you see how that rope is like
Come together.
So it's just each strand in that rope or each bit of that rope is one code or one instruction and another, so and it just tied down that way. So what the virus would just do is to take that thing that contains information about itself, insert itself into the host DNA or send some information into the and then ask it to make more copies of that. Yeah. So when you look at the DNA, it's like an instruction manual. So it's just it's like when you are trying to you've typed up something, but you need to distribute it to 1,000 people. So how do you do that? Are you going to sit down and start typing each one again? No, you just put it into a photocopying machine and it just churns it out. Yeah.
So is everybody's DNA different, or do we all have the same DNA?
So there is a basic. Every living thing on Earth shares some similarities in their DNA.
Okay.
Right? Literally, we share about 99% of our DNA with monkeys, and you wouldn't believe it, we also share about that same number with pigs, right? But human beings are all completely different to pigs. There are differences, so that's why I look different to you and Fumi. So each of us, when we inherit, so we have when every child gets half the set of instructions from their mom and the other half from their dad. And then,
that's X, Y, or what?
Well, that is chromosomes. But all those instructions are in the DNA, in the chromosome. So you get half set of that instruction from your dad and half of it from your mom, which combine to make an individual that is neither mom nor dad.
I think that's important because when you think of every single child or every single baby, each one has its own, his or her own unique DNA coded information. They're not the father, they're not the mother, they're actually a brand new unique individual, which is amazing. And I remember you explaining that it's like getting IKEA and getting a set of, I don't know, how to make a bed instruction and get all the wood and you need the instructions to make it. Now as a female, I need the instruction manual to follow it A, B, C, D. Some men don't. But without the instruction manual, you cannot, if it's especially complicated, you cannot make the bed
product,
end product, and you know, if you have a screw loose left, or you go, okay, something's wrong here, that needs to go somewhere. So the instruction manual is critical to actually making the bed that you got from IKEA or wherever. And I'm guessing that's the same with DNA. Your DNA is your instruction manual for your body to know what is happening where, how to create what cells, and how certain things should function in correlation with the other parts of the body, X, Y, Z, the whole thing. You cannot survive without your DNA. What happens if there's a bit missing in your DNA? Because that's an evolutionary thing that, you know, I'm not going to go from non-living to living because that's complicated. But can a human being exist, or the process starts happening and then you have something missing from your DNA, or add something to your DNA? Can you add after you've already been born and your DNA goes, oh, I haven't got this bit, and then it's added to it, or you get a complete? It's complete when you create it.
So what happens is that you get a complete set of instructions, but every now and then, because it's because it's a copying process each time. So if I write a table of instructions here and I give it to 5 people to copy, the first generation of people might copy it exactly as I go on, but by the time it's gone like 5-10 generations down the line, some people might introduce errors or miss out a few things, and therefore that instruction has changed. So every now and then during the copy process, there is a little jump or a little insertion here and there, and that is what introduces variations. But those variations could either be for good or bad. So some of the illnesses that we have, some of the genetic illnesses that we have been as a result of the incomplete copying of the instructions or something else being added to it, and therefore some people are affected more than the other.
But the original the original set has to be a complete set,
yeah,
or
yeah,
else
yeah,
you will
yeah.
not have a life.
If the set is not complete, like let's go to the chromosome part of it, right? Some babies actually have 3 chromosomes in them, and then the chances that the pregnancy will survive with 3 chromosomes is very, very slim, because your body will just look at it and like, okay, this is not a normal baby, and then it automatically aborts it, right? Because it knows that something is not right here. Only very rarely do you see people who manage to carry it out, and then some of these have some are children born with abnormalities in yeah. So but I'm not, the errors do happen at times, but then the baby, you will still recognize it as a
the baby is a human baby,
yeah,
with a
yeah,
complete set of DNA.
So, well, let me bring a bit of a swing on this. People, especially evolutionists, would look at that and think, you know, if God is so great and God is so wonderful and God gave him rights first time, then, you know, why is there babies born with disabilities? Why is babies born with life-threatening illnesses? Why babies die in the womb? And all these, I mean, these are big, heavy questions. But in terms of, if you, like you said, if the DNA is perfect at the very beginning, then where does God come in all of this? I mean, I don't know if you can answer that question, but you know, even your job as a scientist, do you see elements of God in amongst all of this? Or because a lot of scientists seem to appear to just deny, and they don't want to go down that road. I've even heard of a lot of scientists losing their jobs because of their, you know, they don't want God in the equation anywhere. So is that something? I know that's a whole bunch of questions in there, but
yeah.
Pick one.
So if you started the there are 4 letters of the well, we represent them as amino acids here, but we represent them with 4 letters, and these are the 4 letters that in various ways combine to make up the genetic sequence. If you started writing out the letters that make up the genetic sequence of every individual, the book will be as thick as, right? If you started writing them out, A, T, B, B, T, A, T, T, C, and all that stuff, the book that you end up with will be a massive book. To tell you how fascinating it is, right? The DNA is literally the most compact storage disk that has ever existed, right? So you know how you buy your memory disk and they tell you it's 1 megabyte or 1 terabyte and all that stuff, and then with all the computer thing going on in the world, they've had to build massive storage places for all the videos and all that stuff that everyone is generating on YouTube, and it gets so hot that they've literally have to go bury them under the sea to use seawater to cool them. Yet that storage gets full. The way the science is going now is that they are thinking of converting all that information into DNA format and storing it, because it's much more condensed. So that tells you how big a storage disk that God has already created. Now, you ask me, where is God in this? Who could ever think of such a complicated storage mechanism? And was this by accident? As a scientist, when I look at all this, I'm like, no amount of accidents could have created it. Somebody on purpose sat down there and created all this. Even I was talking about bacteria and all that stuff. When you look at the way each bacterium functions, if you're an engineer, you know that you need your gears and your pulleys and all that stuff to make. There's simple parts of a bacterium, like the flagellum, that makes an organism move in any way. The machinery that goes on in it, you can see the way it's assembled typically looks as the way these days it's all about electric motors, and the way that natural thing has been assembled, it's almost akin to a modern day electric motor, which we have just learned how things work, but it's been there in existence. And an electric motor doesn't just fall together by itself and start working. Somebody has to put it together. Therefore, it tells you that there's an intelligent being somewhere who has put these things together, and every time your body looks at the instruction manual, they know exactly what to make. Every cell, the cells in your body are that's why as you grow older, your body cells only live a certain number of days, then they have to die and be replaced with new ones. Those new ones are copies of the old ones. How do they know how to make the new cells? They have to go back to the instruction manual each time to say, oh, this cell has to be made. And the fascinating thing is that each of us starts off at one cell as an embryo, right? By the time that single cell has been made and they divide up a bit, at the early stage it's just multiple copies of the same cell. But then at some point the instruction manual says some of you have to become eyes, some of you have to become noses. So they all go back to the instruction and my job is to become an eye, and they go off to work one pattern for my job is to become a nose, and before you know, you have a full individual. But the instructions for your eyes, for your nose, for your hands, for your feet, for your skin color, everything is right there in the manual.
So when the Bible says that we're fearfully and wonderfully made,
that is it, exactly.
That has a totally different meaning to you than it would for your normal person.
Yeah.
Because when you're looking beyond just what you could see and feel and touch, and there's a lot more going on with that.
Yeah.
I think it's so important, because when people tell us, or when we're told, should I say, that something evolved as if it has its own mind to know when to change, you know, from a non-living to a living thing, or from one type of living thing to another completely different type of living thing, you know, it's just mind-blowing, because it's not, if you're telling me that there is no way, you know, the underground storage that they're thinking that they have, you know, somebody had to design that. Somebody had to have a mind, or a group of people had to have a mind to say, okay, what we've got now is not functional, it's not enough, and it's you know, whatever, we need to build. So there's a thought process, then there's an action, there's a plan, there's a design, and when people get together, identify a place. So there's all these pathways and all these processes. Nobody ever says, actually we'll just blink and it will happen.
Yeah.
So why would something although complicated compared to DNA, is nowhere near as complicated, because again they're thinking, oh, look at how DNA looks, look at how compact it is. Actually, why don't we follow that? If what you're doing and what we're saying needs a mind, needs time, needs a process, needs organization, how can anybody have the audacity, and I have to use that word, audacity, to tell everybody else and stand by it and say a human being with DNA and any other living organism, including bacteria, including the one-celled organism that is now we're seeing is so complex, the way it's engineered and working, how can anybody say that just happened, it was a random process? Because random processes, in science, you don't trust random processes.
Yeah.
You have to wait and say, is this working? Can this work? Is this probable? And you go step by step. You don't randomly think and hope that it will all work. So why would, I don't understand why anybody would believe evolution and a random process and trust it.
Well, when it comes to that, there are two things that are going on here, right? As a scientist, I believe in what I call macro evolution. So on the
don't make it big. Simple words.
On the larger, macro means big, and then anyway, micro is a smaller. Sorry, I believe. Sorry, me. You
believe in micro?
I believe in micro evolution, not macro evolution. Anyway, so what is, there are small changes that do happen. Like I said, every now and then some mistakes are made, and that is what introduces variety. And so that process is useful for, say, when COVID came, right? Lots of people got ill, but some people were able to survive it. Everyone has heard the expression survival of the fittest, right? Yeah. So sometimes it's people who have had certain small changes in their DNA and other stuff. When a big illness comes, it doesn't completely wipe everyone at the same time, because if we are all just perfect copies of each other, then it will be easy to wipe out everything. But those small changes enable a small group to survive and then carry on with the process of life. That's why the Spanish flu, they now wipe we've had plagues, we've had all that stuff, and there's always a remnant left each time each of these happens. Where the problem is changing from one form of organism to the other.
Before we go to that into the macro, with the micro, even that in itself, I mean, when I was growing up, we learned it and we were taught that was adaptation.
Yeah, adaptation.
Rather than the way the scientists actually explain evolution to you. But we won't deal with that because that's another video for anybody who wants to know. But even with the adaptation and that, it's still not a random dismissive process. Your body still stays within certain coded principles of your instruction manual, which is your DNA. But either changes in circumstances, environment, or whatever can trigger or affect it. And I think that is important. But at the end of the day, with your micro or your adaptation, the human being or the organism still remains that human being or that organism. You still identify it as that. Okay.
So again, in layman's terms, so when I'm thinking about micro evolution, I'm thinking about small changes. So you could have two dogs that have a relationship, and they'll have another dog, but it could be a different breed. Whereas macro evolution is saying the same two dogs get together and out pops a dinosaur type thing. It's just like ridiculous. Because I think that's important when we were talking about in Genesis 1, and that could be what you're referring to a little bit when he talks about that the animals and even the birds, the trees are according to their kinds. It's mentioned over and over again in Genesis chapter 1. So is that what we're talking about here?
So if you look at it, it's apart from a few instances, maybe you bred an, is it a donkey and a horse to get
Yeah,
yeah. Or, but then you can see that they are still closely
but they're still
related.
animals and they're still related.
But you couldn't just suddenly go and put a donkey and a tortoise and then you get some, or you know, when all these mythical creatures of a half human, half fish. No, that is not possible because the genetic makeup doesn't allow for it. Literally, even if the initial fusion was going to happen, the animal carrying the pregnancy will quickly recognize that this is abnormal and an instant abortion is going to happen. Yeah.
So what you're saying basically is a macro change from one type of species, one type of kind, to another type of kind of species. It's not, in terms of what we see, observational science, that is not possible. So evolutionists should not tell people that that is possible unless it's something that is observable in a lab or out there in the world.
Although when it comes to the, so one thing about science is that it's a series of experimentations, right, over time, and you make your conclusion. So you create a hypothesis, you test it out, and then you reach a conclusion in the
and a hypothesis is a theory.
Right.
Okay.
So you then decide whether your original hypothesis is correct or not.
Okay.
And then if it's not correct, you go and make iterations and do your experimentation again. So when it comes to this, we've not had observable things showing that's logical change in this sequence. What has happened is that we've coupled up a few things anyway, and so we can in terms of the human being, they are trying to show this sequence of evolution from an ape to the current humans that were. There is some information in the DNA that shows a relationship between these organisms anyway, and there's like genetic trees and all that stuff. But like I said, a human being shares 90-something% of the DNA with a pig, right? That is why in certain surgeries they are literally use parts of the pig
of an animal,
to create like lungs or other stuff valves that can be, or valves that can be put into a human being. But then a pig and a human are, you can see it with your two clear eyes that they're completely different. So that similarity allows for certain parts to work, but you can still tell that there are two different species.
To me, it kind of says that I'm not surprised that there's certain elements of an animal in another type of animal or in a human being. I'm not surprised about that, because it reminds me of somebody who is an artist, and they can have different types of paintings, different types of drawing, depicting different things, but you can see their signature in how they paint, and you go, wow, this is a Rembrandt because of this, this and this. You know, and that helps to identify. To me, it's just telling me that there's a particular person with a mind, a genius, mind-blowing mind, that has made an animal, has made a human, and is still using the same type of qualities and the same type of some, not all of it.
It's like
to actually make them, but they're not the same.
When we went to the Chinese restaurant and we looked at the menu, and I'm like, how can a restaurant possibly serve all these things? And you said, oh, they just make the base sauces, right? So it's the base sauce that is common in all these things, and then iterations of it are then made to give you a wide variety of creatures all over. So yeah, it takes intelligent design. And in all honesty, no matter what science is doing now, is that it is, if you can Google intelligent design and all that stuff, right? Yeah, science is gradually recognizing that there is some form of intelligent design behind all these things.
And I guess the thing though is going from intelligent design to who is that intelligent?
That is where the problem.
Intelligence behind the intelligent design. Because intelligent design itself is just a phrase.
Yeah.
Somebody must be the designer of what is intelligent.
Yeah. So at some point they are recognizing that there's an intelligent design, but to fully come out to say that the genius behind that intelligent design is God. That is where we have just stopped short.
And that's the shame, because you have the Bible is the collection of writings for over a period of years, few thousand years, and yet this information has been in there, and now it's taking us 2000 plus AD to actually go, oh look at what we found, and the Christian is saying, but actually it has been here all along, and that's what we've been telling you. The design is there, the instruction is there, the manual is here.
Yeah,
it's impressive.
There's a whole load of things. Like, let's say one thing, I think in the Psalms it says he lives on the circle of the earth. Right? Yeah. So all this while in the Bible, it has told you that the earth is round. But our forefathers believed on a flat earth. And it took a little bit of science experimentation to find out, oh, actually the earth is round. But it's been there in the scripture.
It also talks about the paths of the
and then, the undersea volcanoes, which were only discovered quite recently. And there are two things in the book of Job. Today, I think it is Psalm 104 where it mentions Leviathan, and another one that mentions Behemoth, right?
Yeah.
For me, because the way those creatures are described almost look as if they are talking about dinosaurs. Right?
Yeah.
And we know that the book of Job is one of the oldest. It's actually the oldest book of it precedes Genesis and so somehow you can see that there is the disparity between the real science and what the scriptures say. It's not that much.
What do you mean by real science? You mean science as in what we call science today? Because what people try and separate God from science, but you can't do that. There is science in the scriptures, in the Bible, just as there is history. There's archaeology, there's geology, there's all that. It's not claiming to be definitive of science or definitive of geology. And people need to recognize that you can have God, you can have a designer, and you can still have science. Because the whole point of the study of science is that you're looking to discover things and make things. You're not making something from nothing. Which is different.
So the only person who can make something from nothing is God.
The original designer.
Is the original designer, and science literally tells us that something has to come from something. So even if you distill it back to the Big Bang theory and whatever it is anyway, and the Big Bang happened and things all started happening anyway. Who initiated the Big Bang? There must be some energy that had caused that Big Bang to happen. So where did that energy come from, and what is that energy? So if you want to distill it down to energy form, then God is the energy somehow. Something made that. There's a cause and there's an effect. So if the effect was a Big Bang, then there must have been a cause which led to that bang happening. It just didn't explode out of nowhere.
If you believe,
the cause has to be in proportionate with the effect.
Fit, yeah.
In that sense. Well, Lawrence, we've absolutely loved this time together, and I'm sure people who are watching will be really fascinated with this. So I guess we want to finish up simply by saying that one scientist said to an evolutionist one time, you know, who created your creator? You know, if God is not the creator of all things, and you're saying we come from ABC, Mars, or whatever people are saying now, you know, who created them is always going to be the thing. But thank you both again, and thank you all for watching, and we'll see you again very soon, Lord willing. God bless. Bye.
Bye. Thank you.